In this video, I am going to walk you through the specific heat of a metal calculations. At the beginning, so you will have something like this in your lab report, a table like this. There is a picture for the mass of the metal, and it will be the same for all three trials because we use the same metal. There's a picture of an empty calorimeter cup, which is really a styrofoam cup with a lid. That will be the same for all three trials. And a massive calorimeter with water. That will also be the same for all three trials. The mass of water then is going to be the difference of these two. Obviously you have calorimeter plus water, calorimeter alone. The mass of water then is the difference. Then you will have an initial water temperature. Typically it will be around room temperature. Now remember, these have to be in Celsius, not Fahrenheit or Kelvin. Although they can be in Kelvin, but in Celsius. And then you will have the temperature of boiling water. It will boil around, right? It will be around 100 degrees because that's where water boils. That's going to be the same for all three trials. Now to figure out the final temperature of the water, you have a table with data, so temperature versus time as it goes, and you will see where, so in the row or the column that has the temperatures, you'll see where the temperature reaches the highest, right? So it will start out low, it will increase, get to a certain point, and then start to decrease. The highest temperature is going to be the final temperature of water. Now let's take a look at the rest of the calculations. Okay, I've kind of chopped up the table so that you have only the data that you need as I'm walking you through here. For the first question, it says for each trial, calculate the change in temperature, the delta T, change in temperature of the water, which is given by the final temperature minus the initial temperature. So you have a final temperature, an initial temperature, and do the difference between those two. Not the temperature of the boiling water. That temperature is only to give us the initial temperature of the metal. It doesn't deal with this water, okay? How do we actually get the initial temperature of the metal? How can we heat up the metal and measure its initial temperature? We do that by boiling the metal in water. That way we know that the metal will reach 100 degrees because that's the temperature in which water boils. So that's why that piece is there. To calculate the delta T of the water in the calorimeter, you do the final temperature minus the initial temperature of the water. One more piece, note that the final temperature of the water is also the final temperature of the calorimeter. They end up at the same temperature, and that's why the final temperature is the same for both systems. For part 2, it asks you to calculate the heat of the water, the heat that the water absorbs. Metal starts out high and it loses temperature, therefore it loses heat. That heat is absorbed by the water in the calorimeter, and that's what we're figuring out. Q is equal to the mass of the water times the specific heat of the water, which is 4.184 joules per degree Celsius, times the delta T for water, which you calculated in part 1. The mass of water you have in the table, C is given to you, then calculate Q. The next part is calculate the change in temperature of the metal. And the temperature calculation, the way you calculate it is the same. You do final minus initial, but the final temperature is going to be the final temperature of the water, because they end up at the same temperature, minus the boiling temperature. That's the initial temperature of the metal. This will be a negative number, and it's okay. That negative just tells us that the metal is losing heat. Okay, here's that data, the data that you need, right? For the, I missed it, but for part 3, you have the temperature of the boiling water and the final temperature of water. You take final minus T boiling to give you the temperature of the metal. Then for part 4, it says take the Q for water that you calculated in part 2 and set it equal to the minus Q of the metal. We don't have a straight way to calculate the heat that the metal lost, but we can calculate the heat of the water that it absorbed. We just did that in part 2. So take that value from part 2, and all you have to do to calculate Q for the metal is put a negative sign in front of it, because water absorbs it, but metal loses it, so have a negative sign in front. So if this from the Q of water, let's say it was 5,000 joules, well, the Q of metal will be minus 5,000 joules. Then you solve for C of metal. The C of metal, right, the formula is the same. It's going to be Q of metal. Once you figure out what that is, let's say it's minus 5,000, is going to be equal to the mass of the metal times C of metal times the delta T for the metal from part 3. Then rearrange the equation to solve for C of metal, and you'll have 3 different values. Once again, just show me the calculations for one, and then write the answers for the other 2 trials. Part 5, calculate your average C of metal. So you take the negative value for Q divided by the mass divided by delta T. Get the C of metal, then here you average those 3 values. Lastly, you know the C of metal from part 5. The C of reference is given to you in the instruction page, so use that value for reference. Then do the percent error calculation and see how close we got.